In this tutorial, we're going to create a really simple class just so you can see how it's done. Now, imagine that we're trying to create a dragon for a video game or something along those lines. How might we do it? Well, I could put the class dragon inside of driver.java that you can see I already have open here, but that's really not how it's commonly done. So let's focus on how most programmers would do this, and then you can break the rules a little bit later if you need to. So what I'll do is I'll come over here to Project 8, and I'll right-click on it and say that I want a new class. And because I'm trying to create a dragon, I'll call this dragon and click Finish. So notice what Eclipse has done for us. First of all, we have a new file, and it's called dragon.java. And Eclipse also stubbed in this class skeleton right here, making a public class dragon. Here's the beginning of the class right here with this open curly brace, and then here's the closing curly brace. That means the end of the class. And also notice that it is a public class, which we haven't really talked about, but because that's the case, class dragon has to be in a file called dragon.java. Okay, so step 1 is already done for us kind of automatically. What would step 2 be? Well, I like to put in the attributes or the characteristics of the dragon, and because this is a video game, I might say something like int x and then int y, so that would be its location, and then we can create something like string name if we wanted to. Okay, so 3 attributes for this dragon, and we haven't gotten into any of the public, private characteristics that you would normally see in a textbook at this point. Okay, so the next thing that I like to do is to put in some kind of constructor. Again, what is a constructor? It is a specialized function that is used to give starting values to all of our attributes. It also has to be named the same name as the class name. And because that's the case, we're in class dragon. I'm going to type dragon right here. And I know that I have an opening and a closing parenthesis and an opening and a closing curly brace. Okay, so I have to give x and y and name some kind of starting value. Now, when you're designing a constructor, you have to determine what needs to be passed in as a parameter. So you ask yourself some questions. Do all dragons start off in the same place in the video game? It could be that they do, but in this case, let's say that they don't. Because that's the case, we want that information to come in here as a parameter. So I could say something like int start x and then int start y. And then we could also ask ourselves the same thing about the name. Do all dragons have the same name? Well, most of the time they wouldn't. So I could say something like string, and why not name? Okay, and I'm doing this on purpose, and I'm going to show you another thing that you can do in Java in just a second. So, because we have to give starting values to x, y, and name, I could say something like this. X gets start x. In other words, it's going to get the value of the first parameter. Y gets start y. And then you might be tempted to say something like name gets name. There's some weirdness right here. Look, I have a parameter called name, and I also have an attribute called name. So the question is, how do I differentiate between this guy right here and this one right here? Well, because of this case, there's actually a special keyword in Java called this. And anytime you see this dot something, it refers to one of the attributes or one of the methods that are inside the class you're working in. So I could say this dot name gets name. Now what's going on here? I'm really saying that this variable right here, our attribute name, gets assigned the value of the parameter name. Okay, so technically what I could do is I could say this dot x and this dot y, and you can see that all of these refer to our attributes up here. In other words, when you're using the keyword this, it's referring to something that's inside the class, specifically one of these guys up here. Okay, so what else might a dragon do? Well, we could change the position of the dragon. We might have something like this. Void go north. And we'll just say that the y coordinate is going to decrease. Let's say that it's going up the screen or something like that. And what else could a dragon do? Well, let's put in something else. How about void print self? So that we know a little bit more about the dragon that we're dealing with. We can tell the dragon to print some information to the screen. So we could say system.out.println and have, how about the name first? My name is, and then plus whatever the name of the dragon is. And then let's also print out the coordinates of the dragon. So I could say, let's say x well, we'll put some colons or something like that there, plus y, and do the same thing for y. And actually, let's format that just a bit so it looks a bit nicer. Get rid of that, and get rid of that. Okay. Also, if you're familiar with Java, you would recognize this print self is going to be really similar in nature to the toString method that we've inherited, but we can't talk about that yet. So for now, let's just stick with print self. Okay. So it looks like our dragon is in pretty good shape, so I can save the dragon. And now we can come back over here to the driver. And if I were to run this right now, you can see that nothing would happen. If I were to click run, nothing has printed out here to the screen. And the reason is because we haven't created any dragons yet. Okay, so let's create a dragon. How would I do that? It's always data type, variable name, semicolon. So again, you can see that here's our data type on the left. The variable name is going to be called D1, and then we have a semicolon at the very end. Just like we've declared an int, you can do the same thing with declaring a dragon. Now, one of the problems with the dragon in its current state is that it's not alive. It's actually a null dragon or a dead dragon. So we have to use the new keyword to allocate space for the dragon and also to initialize the attributes inside that dragon to some kind of starting value. Remember, this is what calls the constructor. So I could say D1 gets a new dragon, and we need to pass it some information. So let's pass it its x coordinate first. We'll just say it's 100. Its y coordinate could be 200. And then its name could be something like Puff. So if we were to tell the dragon to print itself right now, I could say dragon.printself, and I were to run it, you could see that we get some output down here. My name is Puff, x is 100, and y is 200. Then we could tell the dragon to go north, and then tell the dragon to print itself again. And we should see that we have a change between where it was originally and where it is now. So you can see my name is Puff, and it's at 100, 200, and then we tell it to print itself again. Its name is still Puff, and then it's now at 100 and 199. Okay, so that's kind of the gist about how object-oriented programming works. You can see that we have a constructor, we have attributes, and we have a couple of miscellaneous methods on the inside. I'm purposely skipping over the accessors and modifiers or getters and setters because you can see those in the book. But I do want to talk just quickly about a static method because that causes a lot of confusion when you first see it. Let me see if I can come up with an example of showing off how static actually works. So first of all, to create a static method, you have to add the word static to it. And that's a simple enough rule, but you have to understand what's actually going on. So I'll create a method here called doSomething, and it really isn't going to do a whole lot. Let's just say system.out.println dragons rule. Okay, so there's nothing really special about this, but there are some rules with static methods. Okay, first of all, we can't access any of the attributes up here. So I can't say something like dragons rule plus x. And there's a reason, and I'll explain that in just a minute, but notice that it's erroring out there. It says, hey, you can't access x up there. Okay, I'm going to come back over to the driver, and I'll save this first. Come back over here to the driver, and I want to show you something. Now, we do have this static method here called doSomething, and I could do something like this. I could call doSomething using D1, and if I did this and I saved it, then you would see that dragons rule prints out at the bottom. But that's really not why you use a static method. The interesting part about this is that you don't have to bring to life an object to call a static method. Instead, what you can do is you can use the class name, which is dragon, dot doSomething. So if I were to run it now and save it, you can see that we actually get that kind of output. Now, you may be asking yourself, why do we even need static methods? That's kind of screwy. There are cases where you would want to have static methods, especially when you get into things like utility libraries. Here's a perfect example. You may or may not have seen this, but there is a math class in Java, and it contains things like sine and cosine and everything else. So what I can do is I could call the sine function like this. Let's say 90 degrees or whatever it is that we want to do. Okay, notice that I didn't have to create an instance of math. In other words, I never said something like math m gets a new math, and then call m.sign. I don't have to do anything like that. I'd like to be able to just say, hey, I need to use the sign function. So that's a perfect use of the keyword static, where you don't want to have to create an instance of an object to be able to use that function. You just want to call that function directly. So let me wipe all this stuff out. Hopefully that makes a little bit more sense about static methods, and you can see that it's just going to be the class name followed by the function name, and you can call that function outright without creating an instance of a dragon if you wanted to. So that's it for classes. Hopefully that clears up some of your questions, and I'll see you in the next tutorial.